This time on Captain Chaos's laboratory, we're going to be working on the SS Specter. This is how it showed up. I didn't take it apart. It was a little cleaner. It was in its package, but it wasn't assembled. When I set it down, I just made sure it didn't break, so I laid it down in pieces. Anyhow, it came with a baggie of other parts. The owner of this tried to fix it themselves. They couldn't figure it out, so they sent it here so I can take a look at it and see if we can get any or all of this thing working. So in here we have the speaker and part of the mast, and I think this little is the screws for the motor. So what I was told is happening is it won't reset, the animation doesn't work right, the sound doesn't work, and two of the lights are bad. So yeah, just a few small things, nothing big, minor details. So if I turn it on, the motor, because it's not screwed down to anything, is just vibrating inside of its housing. Those two screws that normally hold the motor on either side they're probably in here. So I'm going to remove the bottom so I can take the motor out so it's not rubbing up against the plastic. Also in the bottom are the little micro or limit switches. So there's the switches right there, the red and black wires. There's the motor. So I'm going to pop that bad boy out so it's not rubbing, so I can turn it on again. Let's see. So yeah, there's oh, that piece is from the bow. The lights that aren't working are on the captain's cab. They're amber lights. All the green ones are working. Whew. Something smells bad. Let's turn that off. What is that smell? It's not that. Anybody familiar knows that electronics, when that starts to burn, has a very distinctive odor. Right now I'm just checking the gears. They seem to be moving back and forth. I don't see any cracks. Yeah. And it looks like the bars are intact for engaging the micro switches, which are those again, meaning that the plastic bar didn't break, so it can actually press on those to let it reverse direction. So let's see if those actually work. So this is spinning in one direction. If I tap these switches, it should spin in the other direction. And I got nothing. Hoping this is the speaker. It is. So let's unplug this so it's not a short. Now let's check the circuit board and make sure all the wires are still attached. So micro switch 1, micro switch 2. Yeah, they're attached. some magnifiers on so I can look at the circuit board a little closer to verify we don't have any burnt components. All the bits and pieces look good. Now the motor could technically be bad and overpowering because it's spinning so fast, which could cause a problem with the sound, not the lights. Get the motor screws out. It's the right speaker, 8 ohm, 0.5 watt. There's the drive belt. Let's put the motor in and see if the motor engages like it's supposed to. So this is just going to be a trial and error set. I don't see any grease on the motor that may have caused it to get a short or damage, but that doesn't mean anything. Could have been cleaned up before I got it. So a lot of times when you have issues like this, it's the motor. Lemax uses too much grease and it causes the motors to generally short out, but occasionally they will overamp, is what it's called, is because some of the windings are damaged, so it pulls more power. There we go. One. And two. Just put the base on so the micro switches will work. I'm not going to put it on completely. I'm just going to put in 2 screws diagonal from each other. That. There's the drive belt. No, it's just jumping the teeth because it's not turning the other direction. So it's not picking up the switches, or the board is destroyed. Bad. No, let's say destroyed, just bad. Motor sounds a lot better screwed in with its tension. I don't think we're having a problem with power. It could be a bad transistor. That's what controls it. The transistor controls the signal from these. The one that's on the right of lower right if you're looking at the mounting screw hole, which is that silver plate. It's got the crappy solder joints that they're known for, but they're all intact. So it's not switching the motor. Why is it not switching the motor? Where's the motor hooked up to? These guys. Motor's just soldered to the bottom of the motor plug. Okay. And the motor is controlled by this transistor right there. There's a smoothing capacitor for the motor. So either the blob chip is bad, the micro switches are bad, or the transistors have failed. Since we lost sound, I'm starting to wonder if the blob chip failed. That's a good indication that you're losing parts of your stuff, is when you lose your blob chip. I'm going to reattach the speaker just to verify the sound part. It's hard to verify the sound when we don't have the ability to play the sound because there's no sound displaying device. So there's one other thing I'm probably going to do once I put the sound back in. I might cut the wire to the motor. If the motor has a problem where it's overpowering, meaning there's a small short, by cutting the power, the rest of the unit will start to run normally. And get a little bit more slack on these to solder them correctly. twist together. There you go. One more connection here, and then we'll try it with the speaker, and then we'll cut the wire to the motor. It's an original motor because it's got the white face. Lemax used the white face motors. It's a standard SR. Hold on. Don't want to breathe these fumes. Whew. It's a standard SRF 300 CA. So, oh, that didn't even stick. That's awesome. There we go. So if the motor is bad and it's causing the majority of the issues, we can fix that. I'm not going to heat shrink those on yet. I'm just going to use them so they don't touch each other and become a short. Because you can't short out speakers. Alright. Since it's not reversing directions, let's not damage the gears. I'm going to take the belt back off. That motor sounds horrible. There is no sound. So, still no sound. We have lights. That's it. So you have all but 2 lights. No sound. And possibly a bad motor, because again, that motor sounds freaking horrible. It should be a very smooth, quiet motor. I think I'm out of them. I have a whole bunch on order, but I don't know when they're going to be here. Oh, well, never mind. I have 2 left. So just to give you a comparison, I am running out of these, so I ordered, I think, 20 of them. Now, if this isn't fully repairable to the OEM, there is options to still fix it. Probably won't have sound, but you can still fix it. Even making it reverse. If you watch the octo swing, that same circuitry put in the octo swing can be put in here to make the boat change directions without using the micro switches. So, here we go. Here's the noise again. And the wires came off. Alright, so remember this sound. now. There's the power. And here's this one. Hear how much quieter it is? So I'm thinking part of the problem is the motor. And the motor may have been the entire problem and it backfed the circuit board. None of this stuff is fused. It's really hard to make it fused. And usually on small consumer electronics, they don't fuse it to begin with due to cost, and the probabilities of it damaging the equipment is much lower than it just failing. When these motors get grease in them from the gearbox, it's very common on Lemax, especially if you have like the Ghost Around or the Roundup. Those are like the worst of the Lemax lines that get the grease in them. Two things can happen. One, they short out completely, everything just stops. Cut the motor, everything turns back on, so you just replace it. Two, not as common, but I've seen it several times, and this is possibly what happened here. Grease got into the motor, so now the motor is pulling more power because there's less resistance, because the grease conducts electricity more efficiently than the coil or the windings inside here, which causes this to push. It's pulling power through this, so this is now getting hot. Well, in electronics, components get warm. It's common, but they have a temperature threshold, and if you exceed that threshold, things can burn or just fail. This blob chip is very susceptible to heat. It's also very susceptible to overpower. And if the blob chip burns, what's happening is when we turn the power on, the circuitry that sends power to the motor imagine a switch. One direction, other direction. So whatever side it's stuck on when the power is turned on is where it is. And the micro switches tell it to flip, but they're not telling it to flip because it's not getting the information either from the transistors or the blob chip. So that's why it's just spinning in one direction as soon as you give it power. The LEDs come in off the power circuit or the power switch over here, and then it uses resistors to prevent the 4.5 volt incoming power from burning out the 3 volt LED lights, or in the case of the ambers or yellow, 2 volt LED lights. So that's why you can have a unit that the lights turn on faster than the animation, as an example, because it doesn't have to go through all the circuitry. It's a direct source with a resistor. So that's what this is doing currently. The direct power stuff, meaning one direction of the motor, and your lights are coming on and doing their thing, except for the two up here, which could be a solder joint, could be a bad resistor that's open, it's not burned, it's just open. Or we have a bad connection at the bulbs, or one of the wires is broke or frayed. Any number of things. In the message I got from him, it said that the lights flicker every once in a while, so there's a bad connection. So I'm going to go with there's probably a bad solder joint on the board, bad solder joint on the lights up here, or the light wire is cracked inside the sheathing and it's arcing. When you twist the wires around, they touch, and then they break free, and they touch and they break free. Lights aren't a big concern. They're super easy to replace in relative context to other things on pieces from the animated companies. So my big issue or big concern is, can we make this function to OEM, or can we make this function as best as possible? I can desolder the transistors and test them, and that's probably what I'm going to do. This transistor, again, controls the micro switch, the two that are in here. One leg of each one is on this transistor. And this transistor right here controls the motor. It's possible that one of these two is bad. And I now own a transistor tester, but it cannot test them inside the circuit board, so you have to remove them from the circuit board. So I am going to do the micro switch one first. So I'm going to get some flux on it to help with separation. I'm also going to take a picture of where the wires go. I recommend that a lot. And that's a good idea. then be very cognizant of which direction the transistor is facing. Meaning that this transistors are shaped like the letter D. The flat side's facing that way, not that way. If you put it in backwards, you will either destroy the circuit board or blow up the transistor or just make it smoke. I've had them where the plastic's cracked and they flying apart like a mini grenade, and I've also had them where they just smoke and where they smell bad and they never work again. So any number of things can happen. I'm going to do this stuff on camera right now just to show you how to do it if you want to buy a transistor tester to test your transistors. These are the components that when I'm asked, can circuit boards be repaired, and I say the discrete components can be repaired. This is a discrete component. What cannot be repaired would be the blob chip. You would need to find a sacrificial piece to fix that. Transistors out. The wires that were connected to the transistor popped off too. That's why I took a picture. That's why we do things in a certain way. So, this nifty little gadget that I picked up the other day is a transistor tester. I just didn't keep the battery inside the box because I'd have to unscrew the box every time to change the damn battery. So what you do is you put your transistor inside this doohickey, which hopefully will fit since it's thinner or smaller than, there we go, that helps too if I open the doohickey. And then you clamp it shut and you press the button. It says this one's okay. So it tells you the pin map and the voltage to pass through. If it was bad, it would say this: unknown or damaged part. So this transistor still testing okay. This is the one that works the flipping of the micro switches. So I'm gonna put this one back in. And that's how you test transistors. If you have a meter that can test transistors, you can use a meter too. Some of the higher end voltmeters can test transistors. I don't think this one can. No, this one can test resistors, capacitors, and diodes. Frequencies, and of course, it can do graphing. And I'm not talking like your scientific calculator from high school. I'm talking graphing for electronics. And if you're interested in owning something like that, I'll put a link to it on Amazon. You have to build it. Well, there's two. One, you build the circuit board and the box, and this one, you just build the box and make everything fit. That's the one I went with. It's also cheaper. So, but you can get a transistor tester to test your transistors. I'd recommend if you do decide to test your transistors, that you test them one at a time. Because if you pop, they're all different. I'll give you an example. This one is a SS8550, and the one that controls the motor is the same, but the one that controls the light is a C1815. Oh, I'm sorry, the one that controls the motor is not the same. It's an S8050. This one's an SS. So, the difference in the letters and the numbers is generally the voltage at which they turn on and off at, and also if they're an NPN or PNP transistor. If you saw that, it said this one was an NPN. If you watch the Octo Swing sets. This is the ones I used on it. I'm just going to show you again real quick. These are called BC 547s. And you can see how long the leads are. That's because they haven't been trimmed. And just pop that in there, click it shut. And if you can tell, it's got a 777 millivolt, and it says it's an NPN transistor. That's why it says NPN across the top right there. Can you see with the glare? There you go. And then you have the C, the B, and the E, which is collector, base, and emitter. Very important. That's why you cannot flip these around, because you'll be reversing them. So now if we put this one back in, so this is 781 millivolts to make it work. And what was this guy again? This one's 792, and this is a PNP. So, and what's also nice about this thing is it tells you that my 9-volt battery is at 8.48 volts, so it's starting to get low. And you're probably thinking, oh, it's just under 9 volts. Well, 9-volt batteries are usually closer to 9.5 to 9 3/4 when they're brand new. So let's put these back. And let's see if we can get this one soldered back on. Too far. And all right, she's soldered in. Now I'll solder the wires back on. Gotta look at my picture because I don't have a very long memory, especially if I take a picture. I don't need to remember. The 2 wires are on the bottom pin. Whenever I solder multiple things, I like to twist them so that way they don't separate as easy. While we're here, let's quickly test the motor transistor. And if that doesn't work, then I'll probably just pause it and test everything else on the board. And see what I can figure out. Now the biggest issue would be the sound, and if I can, I'm still working on trying to find a way to replace the sound components on these, meaning that if the blob chip gets damaged, we can emulate the sound. So I haven't given up on that. I showed you one of the options in the Octo Swing series. There we go. You don't want to overheat the components. You don't want to hold heat for long periods of time. That's an NPN. Says it's good. Watched a really old video on LED lighting, and the guy was showing you this meter, and he mainly was using it because things that come from overseas, like these components, sometimes aren't the greatest quality. So he did it so he had a way to test them prior to installation to make sure that they actually functioned. And their tolerances, because everything that's electronic has a tolerance. It's usually between 1 and 10%. So I can take all those transistors I used for the octo swing, and I can test each one and get the ones that are closest in tolerance. So this little guy here is something you probably will never technically use unless you're into building your own electrical circuits and you use different components, especially if you go old school, meaning that you're not using Arduinos and integrated chips, that you're actually using transistors and resistors. You know, the greatest invention to electronics was transistors that changed the landscape of how things went. It all went uphill from there. So, but anyhow, I'm going to check the rest of these as best as I can. See what I can find. This one shares one leg with the motor. This guy here, the one to the left of it, I'm not saying it has anything to do with it, but you know, it does share a common leg. But it also shares with the blob chip. And so does that one, because of course it probably has to wait for that signal from these wires. And that's the sound. That's the amplifier chip, which that goes around to the blob chip, and your volume knob, which that feels good. It doesn't feel sloppy or loose. So unfortunately, this one may not be fully repairable. That's very common when the boards get damaged. But I'm going to keep testing it to make sure it's actually not a damaged board and it's just not a bad discrete component. So I'm going to check the resistance levels of the resistors. If you've never done that before, I'll quickly show you how to do it. You need a multimeter, not a voltmeter, but an actual multimeter. A lot of people use the names interchangeably, but when it comes to doing electronics, you kind of sort of need to know the difference. So we're going to set this over to resistance, which is the ohms symbol. And again, this is if you're new to this. And you got to pick both sides of the resistor. Doesn't matter which way. Resistors are unipolarity, meaning they don't care which way you stick them in. And that one is basically 1 k ohm. It's 0.99 k ohms. It's 1 k ohm plus or minus, and this is a silver band, so I think it's 2%. Which would make sense. And the one next to it is also a silver band. Gold means the highest, one of the highest tolerances, and the one next to it is also 1 k ohm, but if you notice, it's a much lower number. That's what I'm talking about. They all have a tolerance. So I'll go through the entire board, test all the resistors. This also allows me to test capacitance. If I press the button, that's diodes. If I press it again, that's turning on the audio, so it's supposed to beep. If I do it again, that's capacitance. Looks similar to the diode, but it's not. And I can test this. This thing's got 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 capacitors. So I'm going to go test all the components to make sure they're all good and make sure nothing is blown, burnt, shorted, so on and so forth. If all the components test good, I'll try and test the frequency going to the speaker, which this can also do. And if the speaker is showing no pulsations coming out of this chip, then either the chip's bad or the signal from the blob chip is bad. So I'm also going to send the owner a question asking if they plugged the wrong adapter in. If they plugged the wrong adapter in, I'm pretty much at that point done with it, because the adapter fries the blob chip 99 times out of 100. Only one or two have I had it where it's blown something before the blob chip, and nothing on here is blown. If you've seen some of the other videos, you'll see resistors that are burnt. They are ashy or white and in pieces. Or the capacitor, like this big guy right here, that's why it's so large, is because it's from the power, will explode. And you'll find pieces of it throughout the boat. One of the other boats I did that they didn't want fixed because they just returned it to get their money back, that's what happened. Somebody overpowered it and it blew up the capacitor, which also blew up a few other components. But the reason the capacitor only won't blow up is this is a 220 microfarad capacitor at 16 volts. These things run 4.5 volts approximately. Most of the power that comes out of these Lemax plugs are about 5. That's pretty common. Again, tolerance. Also, free float, meaning there's no load. Once you put a load on it, it drops. So this can handle 16 volts. So for it to blow up, it means something in here has to be shorted that causes this to get super hot. Or you plug in the wrong adapter, like a 12 volt, and because everything in here runs too fast and gets hot, this will detonate. And I don't see any signs of that. So I'm thinking maybe this had a 12 volt just for an instant long enough to burn the chip. So I'm going to do some more testing. I'm going to email the owner, and when I come back, I'll let you know the status of where we're at. That way we're not wasting so much time again on these boats that have a problem working. Because we're already at 43 minutes. And we haven't done anything other than start diagnosing. So I guess I'll be back in a moment on your end, and I don't know how long on mine, but we'll be back shortly. Alright, we are returning to the SS Specter. I spoke with the owner regarding the issues, so I am going to just keep the lights on, and we're going to add sound to this. And if you watched the previous video, you know that I've started trying to replicate the sounds that these came with. So I use the Easy Soundboard, or Easy Sound multi-play file recordable sound chip system that I got off of Amazon. And there's a video that's prior to this that says the title is something along the lines of possible way to recover, or possible sound replacement for Lemax, or Lemax possible sound replacement. I don't remember. I just sent it off to the editor. But in that video, it shows you this and this. This is the original speaker that came with this. In the video, I used a test speaker. I'm sorry, this isn't the original speaker. The original speaker was blown. It had a bad cone. This is a replacement, but it's the original power. So plug in the chip, and then green lights. So this is what we're going to install in the ship to give it its sound. Motion I'm not going to be able to do anything with unless I can find a circuit board. I have gone through lots of Lemax pirate ships and regular ships, and the SS Specter is the rarest, not only because it was a lower quantity made, it's the only ship that rocks left to right. Every other ship is front to back. Of the rocking series, because there are stationary ones that have like paddle boat wheels, they don't rock, but of this style. So I tried taking, because I do have parts boats, but none of them are the SS Specter, they're other boats, trying to convert the front back motion to left right. was not successful. The mechanism's too tall to fit inside this boat. It wasn't designed for it, so it can't do it. The other boats are physically taller. This section of the body is higher to compensate for the taller, because you can see how low profile this is, taller mechanism to make it go forward backwards. So I tried a few different ways, and, well, I didn't have any success. So it's a shame, because this boat just has solid green lights from all the videos I could see, which it still does. And it made sounds, which it does, and it's almost a 1 minute long soundtrack. I'm actually kind of impressed. It's 55 seconds, and then it rocked left to right. And I even watched a video, no joke, yesterday that was filmed when this boat first came out, in decent quality. When it first came out, cameras weren't as high quality as they are today, of course, where this was used on a display in another state. And I looked at that boat specifically in the video just to see if the lights flickered, changed, nothing. But in that video, they also didn't have the sound playing, so it was just the boat rocking and the boat lit up. So I had to go online. I just found a couple of videos with the soundtrack, and I transferred the soundtrack to this right here. That previous video, if you watch it, shows you how to use this. Now, the only downside is that you have to press this button to make the sound. And then once you press the button, the sound doesn't stop until the soundtrack runs out, which on this is 55 seconds. So if in a display, it might be beautiful, great time, the whole nine, or you might be like, oh, I just want to turn it off. Well, that means you have to unplug the boat. You have to stop the power going to the circuit board here. The volume switch isn't compatible with this volume switch. This is a 3-wire volume switch, and this guy is a, I don't remember, 2. Because this uses a linear rheostat, which is different than the, well, this technically would be close to the same, but this being a round wheel, this is just going to be the off-on for the lights, and it does nothing more. And then this button, which may not be using this button, but we're going to remote the button out the back, try and make it somewhat inconspicuous so that it can be pressed to turn on and off this, or excuse me, turn on the sound, and let it do its 60-second soundtrack. So I have already, before I started, I did, as you heard, I soldered this into the incoming power, which is this guy. On this boat, it is white and gray. White is hot, gray is not. That way it's soldered up inside here, so I can put this board back up inside. I'm going to leave all this mechanism in here. I'm just going to have the motor disconnected, which is this black wire that's dangling right here, and it's over here as well, where it's cut. And the reason I'm doing that is there is always a chance that a circuit board may be found, and then we just pull the circuit board out, cut the wires, solder in the new board, remove this circuitry, because you won't need it anymore, and you're good to go. So there's always a chance. It might take time, and it may never happen. So in the meantime, we're going to leave all the factory wiring in, which makes it kind of a mess, but I want it to be able to be salvaged if we ever come across a parts boat, which is pretty slim, but there's still a chance. So now I'm going to slide this circuit board up inside. This circuit board is a, what do they call it, a power regulator. Jeez. So I have 4 volts coming into the board, and there is 3.9 volts coming out to run this. I'll get my glue gun started so I can glue this board up inside, because what I'm doing is I'm sticking the board up into the passenger compartment. There's in the bottom of these boats, there's a hollow spot from the casting. This board almost fits perfectly. But to hold it in place so it doesn't fall, and I know there's no motion, but so it doesn't fall if they're going to get bouncing around in here, I'm going to tack it in place with some hot glue. I'm going to do the same with this. I'm going to tack this board on the inside as well. The main board technically doesn't have to be tacked because it actually fits up at an angle, and once you stick it in, it grabs itself on the porcelain casting. I probably will still put a little dab of glue on it just to keep it from moving, but the way they designed it, the board fits right up in here, right here in the aft of the ship. So Just gotta wait for that to get warm. So in the meantime, this is what we're gonna do. This button is probably going to be a little too short for what I need, so I'm going to have to either extend it or change it to a new one. But first thing I need to do is get this in. I want to get the speaker in, because the speaker goes into the bow, and the noise comes out of these holes here, because the speaker faces forward for some reason. I might face the speaker backwards just to have the sound permeate throughout the whole boat, so it's more of a surround sound versus a directional sound. And then once that's in, I'll see where this fits the best. I know there's a lot of wire here. If I can't coil it in there, we'll cut it and make it shorter. And then either use this switch or a different switch and figure out how to remote it down to wherever. Probably want to put the switch somewhere on the back of the water casting. Not warm enough yet. So this is where we're at on the SS Specter. And then once that's done, this will get glued back in and then clipped onto its pins. There's one there, there's one right there. And the ship will be reassembled. And then I'll whip out some hard glue, not hot glue, and we'll fix the broken pieces. And then that'll take care of this boat for now. So it's gone from one function, being lights, to two functions, being lights and a sound. So at least it's a static prop, but it's a static prop that has lights and sound. It's unfortunate, can't fix everything. I try. I've had this for a while, trying to do whatever I could to make it work. And I've been scouring. I even had somebody who is really good at doing circuitry try and figure it out, and surprisingly the blob chip looks great, but and all the other components that I was testing, I was showing you that transistor tester, the capacitors, the resistors, everything tests within tolerance, everything, and yet it doesn't work. So my only conclusion is the blob chip is bad, but you can't test a blob chip. Especially because you have no access to the circuitry underneath. So the assumption from myself and one other person who I sent the information over to, they're not in the country, so it's always just done by email, is that the blob chip has somehow failed. Whether it failed from overpowering, age, something. But we can't determine, considering everything else works. I'm just not getting good power to the sound. There's no signal going to the sound chip, and that signal comes from the blob chip. So that's why we're just going with the I don't want to really say assumption, but the assumption is the blob chip has failed in some capacity, whether it be, again, from a power problem to just fatigue to overheating, moisture. The blob chip looks, the bakelite, the resin, whatever you want to call the black blob they put on top of it to give it the name blob chip. There's no cracks in it. Not like some of the other ones where they're cracked and bubbled and they're pockmarked from getting overheated or overpowered. This one just this one's just not sending a signal anymore. So, and I know this ship is notorious for having problems. The SS Specter has the most problems of the pirate ship series, and it's probably because it's more advanced in circuitry and for the left-right motion, because the other ones just use a cam that makes it rock back and forth. This one uses micro switches. That's more circuitry, more logic stuff. And I think that's why we have lost everything, is part of the system has failed. So now that the boards are in, let me see where we can stick this one, so I know how far we have to extend these wires. Now if you do use this same pad, it is double back taped onto the disc. This is what it looks like if you didn't watch the video. So the speaker, the battery, and then this is the circuit board. the battery I removed, and that's why we use the voltage regulator to imitate the battery. And then I removed, well, the speaker, because I was going to use the factory speaker, but the factory speaker had blown cones. I had to replace that speaker too. And then I soldered on the speaker wires from the Lemax unit, so they're longer, so I have more play. So, but now it's this. This is probably going to be way too short, unless I like just stick it on the side of the boat, and that would be really stupid. And I don't really see anywhere on the deck that it would blend in. You know, so you can just walk up and, you know, press a light or a button, but there's nothing up here. So I'm just going to extend it to the back. So I'm going to use a length of wire. And I'm going to go a little longer than I probably need. Actually, I'm going to go with some thinner wire, because this is really thin. I don't need the thick stuff. It's just a switch to tell it what to do. So let's go with something a little thinner. So this is 28 gauge. And this is almost as thin as you want to get. They do make a slightly thinner insulated wire, but I don't usually go any smaller than that because it's so fragile. This here is probably 30 gauge. So it's really close. And I'm going to strip this one back now. So where the switch is soldered, which is right here, I'm going to add a little flux because I'm going to remove the switch completely from the circuit and relocate it. So to do so, I need to get rid of this solder pad set right here. Also, these Chinese wires are really susceptible to heat. This insulation, like, it's all melty and gummy. So we'll probably just replace the wires to a little bit better quality. Also, they'll be copper. So we're going to tin the wires. So if you happen to have a working Specter, be grateful, because every one I've come across has been non-functional for a multitude of reasons. Usually it's always the circuit board. One of them, that the previous video about this, where the board had literally caught fire and the person had a return ability. Then I had another one that the board was completely dead. No matter what was done, nothing worked. At least this one had lights and a motor that spun in one direction. And then there's this one. So I don't know what the big causes are, but this ship seems even more susceptible to problems than the others in the pirate style boats. So now that I have my wire soldered on, I'm going to put a bead of glue, just like they do from the factory, because here's another one that I used to test. You can see the glue right here. They do that to prevent the contacts, and also it's a strain relief to prevent the wires from snapping where they're soldered, because that would be their weak point. So I'm going to run a bead of glue across the solder pads, like that. And it'll hold the wires and insulate the actual contacts. Now I'm going to try and feed this through the same hole. Probably should have done it the other way, fed it through and then soldered it. That would have made sense. Where the actual black power and on-off switch wires go. we go. Because doing that will tell me where I'm going to place this circuit board. And I have a big flat spot right in here that this should fit nicely. Yep. So let's tack this thing in. We're going to put some glue on the back of the board. And then push and hold until it cools down and pull out some of that slack. And I'm going to flip this so you can see what I'm doing in here, because all you see is me sticking my fingers inside the bottom of the boat. You have no clue what's going on. You're like, I can't see it. I don't know what he's doing. So you can see how the circuit board for the power supply or the voltage regulator slides up inside, fits perfectly. And then there's the flat spot, which is better than the other side that has the wires, that I can stick in the soundboard. And both of those will clear this. So now we just need to do a little wire management in here, which is going to take just a second. I'm going to put some of the excess wire over here. Oh, and then the speaker is up here. You can't see it because the whole point of it's to be in the front. So next step is going to be the wire management, and these wires I'm not going to glue, mainly because if this ever has to come back out, you need to be able to have all this slack. Now if it ever gets repaired where we have a new circuit board, then we'll have to glue these to the inside lip like they had originally, like right there. But since they don't do anything, I'm not going to glue them. I'm just going to push them in because they're not doing anything. There's no motion, there's no nothing. That's the right one. That's the right one. Because I need to get this thing glued in so it can cure. So I can clip this back together. Oh yeah, one other thing I did do to this while this is cooling down and getting hard is I did remove all the old glue that was on this bottom piece. It's pretty standard. Sometimes you see me do it on camera, do it off camera too. But that way this base is all fresh and clean and doesn't have any of that old hard crusty yellow glue. So now hopefully it will cure and be stronger with this clear glue. Yeah, this yellow, clear, crusty stuff. Alright, so there we go. I'm going to run a bead now on the front and back in the gap, just to fill it in. Because this is the only thing that holds this to the ship. I'm just going to fill in any of the spots where the glue is wrinkly and try and just make it all level. Like that. There we go. Lift the insulation, or should be the bottom pan up here, pull that through, pull these through, that should get lined up in the hole. It's not just those two tabs, the front and back, that pivot. It's also the fins that make it pivot are also have to be aligned. So this is actually a little bit more difficult than it looks. Normally you'd unscrew the bottom, but since he didn't take the mat off, I don't want to destroy his mat. Might have to take the mat off. Actually, what am I going to do with these? There we go. Well, get the front end first. The front pin is longer if you do it this way. The correct way is to actually remove this big foam mat from the bottom and then remove the screws and take it apart section by section. But when I got this, the mat was still attached, so somehow he got it apart. Probably just used a screwdriver and popped it off, or it just fell off, or he pried on it. I'm not sure. Because the only part of the mat that's been affected has been right here where the power wires go through, and that's it. So, but now it's on. It wobbles, and as you can see, it's the bottom stays on. Just grabbing it by the hull. Right there. So I'm not doing anything special. If the wasn't connected, even with these wires sticking through, the front would fall down first. So now that we have a lot of extra wire, like I was talking about, we can either try and use a big button like this, or we can use a little button. But my little button case, I think, has been moved because, again, moving this laboratory, I was doing it this morning, had a little help, so we were moving some of the items. Oh no, I have two cases with buttons, and apparently the other one's sitting right here. Once I move this stuff out of the way. And here's my case with buttons. So you can see I have a variety of buttons ranging in multiple sizes, and even got these small little guys that might work decently. We might be able to tuck one in, because just to give you an idea in size relationship. There's that button, and then here's that button's gone now. So this entire thing is smaller than the button itself. And then I have square ones and green ones and all sorts of fun ones. Let's put that with the rest of the same size guys right there. So we're probably going to go with the itty bitty guy just to be safe. Let me see, where's the best spot to put this? First, let's get that there. So probably right above, there's a big indentation right here or right here that I might be able to just put the wire up against and then just glue this little guy into place. Got a lot of small stuff, so it's got the 4-latch case. That way, in case it ever falls, hopefully they won't spill everywhere. There we go. haven't done is since we've put it all back together, make sure it still makes sound. So let's solder this button, or touch this button, and make sure that we get sound. Actually, the button doesn't matter. I can just touch the wires together. It's a momentary, so you just tap them. We got lights, as you can see. And then we should have sound. Here we go. The button I dropped, don't worry, I'll pick it up. So what I'm going to do is I'm going to bend them out a little bit so I can see what's the best fitting to put them right, that button right in here in the wave. And I might even have some blue insulation that we can cover this with. Oh, look at that. So it'll help blend into the water. And I know it's not the same shade, but it's probably better than yellow. I'll just pull out a couple sections of it. So since we're going to put it right into this crevice, which it looks like the best place for it, I'm going to need to cut off that wire right there. Now, of course, if this boat has to be opened, you'll have to pop the hot glue off of this to provide slack on the switch wires. That's the only downside. That should do pretty good. Just gonna get the blue a little farther in, so that way I can get this on and push down some way so I can strip these wires and then solder them. So since that's about where I need it, we're going to shrink this down. I think I'm running low on fluid. The lighter I always use, I bet you it's empty. Yep. No more gas. I guess we'll use the heat gun. It's just not as fast as a lighter. You have to wait for it to get warm, and that is what it is. And with it shrunk, I can slide this piece down so I can strip this, solder it, and then slide it back up. Because that way the soldering iron doesn't cause it to shrink from the heat from the soldering iron. pre-tin the wires. And again, because all the switch does is make an instant contact, there is no polarity. There's no one side has to be hooked up and the other side in a certain order or anything of that nature. It's literally just a momentary touch. Once it gets the signal that the wires have touched, then it turns on the sound. Now I'm just going to solder the wires to the switch. Like that. Apparently I cut through my solder. So I'm going to quickly solder it again. I'm just going to add a little flux to make it a little easier. There we go. And let's make sure the switch works. Test it again. No. That's what I thought. It didn't feel right when I was pushing the button. The switch is stuck in. So, replace it again. That's why I like to test things before I make them permanent. It's because defective stuff does happen. These buttons are really stiff. What if we try a square button instead? Oh, that's a lot softer. So I don't want you to have to push so hard that you, well, break the unit. That would be bad. Throw that one away. And just going to add some flux and pre-tin these. And this might actually fit better being rectangular. Might fit better in the groove. The groove is longer than it is wide. There we go. Power again. Anytime you repress the button, it restarts. So I'm making sure the button works, since it didn't want to start the first time I pressed it, which may have been I pressed the button too fast for it to connect to the board. Also, I just realized my solder joint sucks. Let's fix this. That's better. That also may have been a problem. How's it now? Good. Make sure your solder joints are good. All right. Now I'm going to slide this blue up. We're going to heat shrink it down. Get it up as high as I can. Right there. I'm going to glue the button in. I'll show you its placement, and then we'll do a low light of the lighting just to see what this looks like in low light for y'all. And then I'll work on repairing this, and we'll get it back to the owner. I'm sure he'll be happy to get it back since I've had it for a long time, trying to figure out any possible way to fix this. While I wait for my hot glue gun to, well, get hot, I am going to just chisel off the glue that's on here, because this glue didn't hold. That's the reason it's, laying right there. I find some of the best ways to get the broken glue off. If you watch previous videos, you'd see me always using side cutters or wire cutters, flush cutters. There's about half a dozen names for these things. And that's because I have a really sharp edge, and then you can get really good leverage on them. So they dig in. Although this I don't think went there. Might have. You gotta be careful with those. No, I'm gonna have to look at the picture on the box. I'm not sure where it went. Is it hot yet? No. It popped out. Front's in. Back one popped out again. I'll get that in a minute. Now it's hot. I thought this came from the front because it was in the box, but there's no broken anything on here. It's the same color, but I don't know where this actually came from. I'm going to have to find a box and figure out where this came from. Because there's no glue on here, and there's no broken resin on here. It looks like it was pinned to something with... Oh, unless this was just pinned in here and it was hanging. No, I guess I'll check the box. Okay, so there's the button. Should be good. Put a little bit of glue on the bottom. There we go. So there's the button. And now I'm just trying to get this plastic finger back in. And where's my heavy screwdriver? There we go. Let me see if I can ensure it's clipped. It's not clipped. Now it's clipped. So there we go. I'm going to go turn off some lights. We can look at this in the low light. And then I got to go find the box, because I put the box back in the box it was shipped in, and figure out where that goes. Because that was inside the box in that baggie, if you remember. Little parts. So, plug it in. Turn it on. So there you go. So if you don't have this boat, that's what it looks like. It actually has a really good glow to it. It's got a couple purple lights because that's the front. So the purple lights help illuminate the stuff that glows in the dark or is reactive to UV. This facing this way is the back. So this is how you would normally have it in your display. It's like this. You can see the UV lights illuminate the stuff that has somewhat reflective paint on it, the other ones down in there, and it reflects a little bit off of the port right there. So there's that, and then if we do a reach around back here, there's the hole, there's the button, which lights are coming back. Unless you want to listen to it for 60 seconds. It's a lot of noise. So, there's the button. You can see it kind of blends in a little bit with the waves. I follow the shape in the plastic water to go back into the same hole that or the same groove that the other two come out of. So you just have to go right here. It's pointing up at an angle. Just follow the wave in with your finger and click. You should be able to hear the audible click. It's a momentary button. So you just hold it for a half a second, let go, and it will start playing the sounds. So at the moment, this concludes the SS Specter with its new soundboard. To see how the soundboard works, I will link below how to get to the video where the soundboard is being tested and the different voltage regulators I used to get it to work, because this isn't the first one. Matter of fact, it's the third one, to get it to function without having any big issues. So it's a shame we can't get it to work like it's supposed to, but 2 out of the 3 ain't bad for something that didn't have a lot coming in and had a very high chance of never doing much of anything other than lighting up. So at least we got some sound going for them. And, well, if we find the remaining parts on a parts boat, we can get this fixed in the future. So in the meantime, this is where we're at. Button in the back for the sound. Still got the lights. No motion at the moment. And then if ever get a board or find another fix for it, we'll come back and revisit it. So until the next one, thanks for watching.